Hi, everyone. Welcome back to another virtual Eclipse community meetup. I'm your host, Laura Tran, and I'm here today to introduce our guest speaker, Maximilian Kogel, who will be presenting about Eclipse Theia and Che. If you have any questions, please leave them in the Ask a Question tab below your screen or in the chat box. So I'll pass it over to you, Maximilian.
Thank you very much, and welcome everyone from my side as well. So our topic today is to look at how to build web-based modeling tools with Theia and Che. And I would like to start with the question, why would you actually like to do that after all? Why not just build a traditional desktop-based RCP tool? And there's a couple of unique advantages to build such a tool in a web-based way. The first one that I would like to mention is accessibility. So you don't have a client installation anymore. Basically, you're good to go just by providing someone a web link. And for some use cases, that's really, really neat. You might all know that from reviewing code on Gerrit or on GitHub. You just need to provide someone with a link and they have kind of an IDE. And in our case, they have a full-blown modeling tool. It's simple to update the client. People just refresh their browser, and the next time they hit the web page, they have an update. And something that we also encountered in actual customer projects that people need for some of the modeling tools, people run quite sophisticated simulations or analysis that require a machine that is capable of doing that in a reasonable time. And people just all used to have that kind of machine. And what you can do, so a machine that's powerful enough, and what you can do quite easily with a web-based tool, you just have that one machine in the cloud that is so powerful, and everyone can just have a quite regular laptop to do the same thing. Then usability, which might seem a little bit counterintuitive in the beginning, because web tools were not really known for their usability, but more recently, in order to achieve a modern UI look and feel, it is the way to go. If you think about SWT versus HTML5, there's just so many more things you can do with HTML5, or GEF versus SVG. So the web offers some unique technology to be able to cope with usability. And then finally, maintainability. I mean, usually those tools have longer life cycles. And if you start a new project now, you need some room for evolution. And obviously, the existing desktop technologies will still exist for some time, but there will be less and less new features, and it will become increasingly difficult to have developers that can work on those technologies and that are knowledgeable about them. Now that we've defined why you might potentially want to do that, what do I, from my personal view, understand by a tool or modeling tool? This is a collection of what I've seen over the time in customer projects. It's prototypical of what people like to have in those kinds of tools. So first of all, they usually start with something like a workbench. So they need window management so that they can arrange different windows with editors. They need often enough some kind of explorer component so that you can drill down in a structural way, or that if you have files and folders, you can view that folder structure. Obviously also menus and the like. Then in many cases you have editors that are form-based. Often they still have a tree to select something from the structure, but then they have forms to represent the properties of some of the elements in this model. Then diagrams is also something that's quite often in those kinds of tools. Some aspects of what is being modeled in this tool is often represented better if it's represented in a visual way, like we can see here in the purple box. So diagrams. Then, of course, even in those kinds of tools, you still have text. So you might have a textual DSL to work on a particular aspect of whatever you're modeling there. Or you might just work with code because you generate some code from the artifacts that you're modeling there. Analysis, that's often very individual how it looks like, but in many cases you have analysis and simulation components that have some maybe more neat visualization to derive some results of whatever you created in the tool. and then generators many times. So that can be a code generator, or it can just generate other textual artifacts such as documentation, so model-to-text transformations. So this is the kind of tool I would like to cover in this talk. Now, all of that is not really super new, right? People have been building those kinds of tools. Web technology is there for a very long time. So why is it now that this becomes a more interesting topic? And I think it is because maybe 2 years ago at most, we were at the point where some of the key enablers are now available that, in my opinion, make it possible to build such a tool in a more cost-efficient manner so that more people are interested in doing it. You were able to do that just on your own by basically building everything from scratch. And I will, throughout the talk, demo the different features, and you will see what I mean by those available components that help you in building such a tool. Key enablers, though, are Eclipse Theia. So we have that in the title of the talk as well. This is an extensible cloud IDE. We will see it in the demo throughout the talk. And it's the default front end for Eclipse Che, which in turn is a Kubernetes native IDE platform. So the combination of both allows you to provide users with a multi-user environment with workspaces and HTML5 based front-end IDE. One thing that I find quite interesting that's a key enabler more in the background is the language server protocol and an implementation that's being used in Visual Studio Code called Monaco. And the idea of that is that by having a protocol, you can separate the editor that actually edits the text and the implementation of the language smarts into a front end and a back end. So you have an LSP server that runs in the back end, and that is language specific. Like, for example, it's an LSP server for Java, and it understands the Java language. So it understands which auto completions you can do and the like. And then you have an editor in the front end that just helps you with editing the text and fetching, for example, auto completions from the back end. Now, with those key enablers, we are now at a state where you can build those kind of tools with a reasonable effort that is not 1 or 2 orders of magnitude from the effort you would have to spend to build the same with what we have available on the desktop based on Eclipse, so with RCP and EMF mainly. Now, having said all that, what is if you already have an existing tool and you would like to migrate? Would you now have to reinvent the wheel? And what are the components that you could potentially reuse? What do you need to re-implement? How do you even separate now between this new front end, back end separation? And I would like to answer that question throughout the talk and the different demos, but also in the beginning with a quite typical reuse example. So if you have a code generator in an existing tool and you would like to reuse that, how can you go about that? To be able to answer that question, first of all, we need to have a look at the overall architecture of Eclipse Theia. And Eclipse Theia consists of 2 main components. One component running in the front end, just the Eclipse Theia front end. It is based on JavaScript and TypeScript code and runs in the browser typically. And then there's the Eclipse Theia backend. It runs on a Node.js server, and also written in JavaScript, TypeScript. In the Eclipse Theia front end, there's things like the editor. In the back end, there's things like the workspace and other components that support the editor, like language servers. If you are adding anything to Eclipse Theia, actually even the core features within Eclipse Theia are done with that mechanism. You can add 2 kinds of extensions. You can add front-end extensions and back-end extensions. And for many features, you actually have to add both. And the front-end extension then adds something to the UI running in the browser, while a back-end extension adds some capability to the back-end. If we look at the concrete example of a code generator, and we assume that you have some Java-based code generator that you had previously used in a desktop-based tool, then this would run in its separate JVM. And the first thing you would need to do, which I highlighted here by introducing the yellow border, is you would have to wrap the code in a way that you can call it from the Node.js server. The simplest thing you could do is just introduce a main method, provide one argument, which is the target location the code generator should generate the code to, and you're done. Now, secondly, you would add a backend extension to the Node.js backend of Eclipse Theia, and that would be what I call the generator launcher. And all it had to do is on the request of the front end, it would on a terminal essentially just launch a JVM with the jar of the code generator and just pass in the current workspace location where the code should be generated to. And that's it. After that call, when the code generator terminates, the JVM basically terminates as well. And now finally, you have to add some UI. In the simplest case, that would just be a menu contribution that allows you to generate code on a particular model file, for instance. And with those components, you would be able to integrate a code generator. The generator UI is super minimal. The generator launcher is as well. So it's not much code that you need to be able to do that. And basically with minimal changes, you can just reuse your code generator that you already had. Now, having touched review, what's the overall tool architecture that we're looking at? And the most important part is how to integrate the different editors in that. And I would like to highlight that. So in this example, we have a form-based editor, which we will go into detail later, but it's a JSON forms-based form-based editor. Then we have a diagram editor based on a technology called GLSP, and we have a textual editor based on LSP. And those three editors somehow need to synchronize their state, because the form-based editor might show something that's also shown in the graphical editor, and likewise the textual one might have some things that are shown in one of the other editors. So in the end, we need a component that is able to synchronize the editors, and that component will be the emf.cloud model server. That's a component from the emf.cloud project, and it allows editors to request parts of the model, subscribe to changes in the model, and then update their state accordingly. We will go into detail about that component later on. I just wanted to make sure that we understand how things communicate in the overall architecture here. Now, the remainder of my talk will be a demo so that you can actually see how those things work live. I will always start with a demonstration of a particular feature, and then I will dive into a technical explanation how that feature was achieved. For the demo, we will use one model, and the example is about modeling a coffee maker and then doing things with the model of that coffee maker. And that one connected model for coffee maker consists of a structural model that describes the structure of the coffee maker, so that the coffee maker is made of a heating element, a water tank, a dip tray, and the like. And it consists of a behavioral model that tries to describe the different activities that the coffee maker is supposed to perform to be able to create coffee. And then we have an example IDE with the following features to work with this one interconnected model. We have a tree editor for structural modeling with forms. We have a graphical editor to be able to edit the behavioral model as a graph. We have code generation to derive code from the behavioral model. We have the capability to work with that code, so to edit that code and to debug that code. We have part of the model as a textual language, so we have textual modeling support, and we have an analysis component that will generate some analysis result and visualize it in the IDE. And finally, we have multi-user support, so we will be able to run this IDE in a workspace per user with the help of Che. Now let's dive right into the demo, and I would like to start with the form-based editing. If everything works correctly, we should have now switched to a second screen where we can see Firefox running. And someone will stop me if this is not the case. And what I will do now is on the terminal, I will run the version of the IDE that we have. So this now starts Theia, and it will fire up a Firefox tab, and this launches Theia. So what we have here is the Theia IDE. On the left-hand side, we have the Explorer. There's also different other views available that we will not go into detail now. And there's also some consoles down here and the menu up here. So what you would probably expect from a typical IDE platform. And in the Explorer, you can select within a file structure. And I have one file that's a model file here. And this contains my coffee machine. And within that, I can create the structure. So I could create some other elements, like, for instance, a dip tray. And a dip tray, I think, can have a control unit. If you open up one of the elements by selecting them here, you can start editing this. And obviously, if you select something else from the tree, that's also being displayed in this form-based editor. So this is the feature of a form-based editor, usually with a tree on the left-hand side and then a form for the different types of element on the right-hand side. Okay, back to the slides. Now, how is that achieved? So for the tree, we have used a component that already ships with Eclipse Theia. It's a Theia tree widget, which provides you with tree capabilities. And basically what you need to implement, if you're familiar with EMF, is a label provider and a content provider. So something that retrieves labels for the different types of elements that we have here. We had control units, dip trays, and the like, and a content provider that provides the children for those elements. So that provides a hierarchical structure. So that's pretty straightforward. And then for the detail forms, so whenever we selected something in the tree, we use JSON forms. And that is a declarative approach where you basically pass in a JSON schema and a UI schema. The JSON schema describes the properties of the selected element, and the UI schema describes how those are mapped to UI. The advantage of that is that you don't have to program the particular UI, so the forms, but you get this provided by a renderer programmatically. The only thing you have to do is to model those UI schemas. In case you don't have a UI schemata for a certain element, it's just automatically rendered. So that's pretty neat to get started. And then finally, there will be a synchronization part, which I will provide more details on, but just for now, that's based on the EMF Cloud model server. And in order to integrate with the EMF.cloud model server, we have used a TypeScript-based client API that's also provided as part of the EMF.cloud project. And with that TypeScript-based API, we can push changes as commands. So whenever we typed something into one of the boxes, we changed the clock speed, for instance, then this would push a command to the model server so that it updates the model in the respective part. And in addition, you can subscribe to updates. So if we would have changed something in another editor, I will show that later on, then the form-based editor will pick up that change and update the form. Now, how does that look like in terms of architecture? So we have, again, the browser and the Node.js server with the front end and the back end. And what we've done is we plugged in a coffee tree editor front end contribution. Basically, what that does is tells Theia that it wants to be responsible for the .coffee file. It will provide a label and an icon for the .coffee files. And then it registers the tree editor that we have created as the editor responsible for those .coffee files. The coffee editor will talk to a model connector, which is a backend contribution, to be able to register for changes of the model and to push the commands to the model server. So the model connector connects to the model server, requests the parts of the model that are required to display in the form, and it will register for corresponding updates. The model server itself runs in JVM again. About the model server, we will get some details later on. By the way, so if you have any questions, feel free to just interrupt me at any time. We have enough time to answer questions on the way. Now, graphical modeling. Let's go back to the demo. So what we have here in the demo in the editor is a brewing flow, which is the workflow of brewing coffee. And it doesn't look very nice in this structural editor because you can't see where a flow goes to and comes from. So you can open that up as a diagram. And here we have a diagrammatic editor, which represents exactly the same information, which is just much more readable as a diagram editor. It has the feature that you would expect, so you can zoom in, out, and you can add nodes. So I can, for instance, add another manual task here, and I can add an edge. And I could call that activity curse. So whenever you drink a coffee, you would end up in that activity. So back to the slides. How is that being achieved? So the graphical modeling is done with a component called GLSP, Graphical Language Server Platform. And the idea of the Graphical Language Server platform is basically the same as for the language server protocol, but just for graphical editors. So again, we have a GLSP client. The GLSP client is generic, so it does not understand the language-specific parts of that particular activity coffee maker diagram. It just is responsible for rendering the graphical visualization and for interacting with the user. And then in addition, we have a GLSP server. This server then is specific to a certain DSL, and it understands the coffee maker activities and how they are connected. And it maps the model of the coffee maker to a graphical visualization. So in our particular case, it would look at the brewing workflow. It would look at the flow edges that are in there, where they connect to, where they come from, and create a visual representation for that. It is also responsible for the synchronization with the model server. So I added a node that would send a command to the model server in the end to add that node also into the model. I changed the name of one of the nodes. That's all synchronization with the model server. And the GLSP itself, so all the graphical representation part, is based on another Eclipse project, Eclipse Sprotty. If we look at the architecture, again, we have the front end and the back end. In order to achieve that, we need to add a front-end extension, basically an existing one. That's why it's blue. It's just the GLSP editor. The only thing that is custom about this editor is you need to define how the shapes look like. So you will have SVG shapes for the things you would like to visualize. That's the only thing you change in the GLSP editor. Otherwise, all the functionality you've seen with the palettes, with creating nodes, drag and drop to create edges, zooming, and the like, that all ships out of the box. And then in the backend, we have a GLSP connector. And that's where the GLSP editor connects to. And the connector is responsible for maintaining a relationship with the Coffee GLSP server, which is implemented in Java. The Coffee GLSP server is a custom component that's specific for that particular DSL. It can use components from GLSP core to achieve that. And it, in turn, connects with the model server again. So if we look at a round trip, if you add a node in the GLSP editor, it will notify the connector. The connector will send that to the Coffee GLSP server. In case it is not there, it would even fire it up. So it also controls the life cycle of the GLSP server. And the GLSP server itself will then look at that change. Is it a visual change only, or is it a change that changes the semantic underlying model? So did we, for example, change the text of the node? Then it figures out what that means in terms of the model. So in terms of our model, it would mean that the name of an activity changes, and it pushes that change as a command to the model server. In addition, it subscribes to the model server. So whenever the name of one of the activities would update, it would also push that back to the editor. Just to get a little bit into the details about the idea of GLSP, there's a number of things that a diagram editor needs to do. So that we have diagram rendering, obviously, so that you can see something. You need the editing tools, so the palette. You need some visual feedback so that you know, for example, where you can connect an edge to. And then there's more stuff like editing rules. So who can connect with whom, commands, what can you actually change and what does it mean, transactions, live validation, and model management. And what GLSP does is, instead of having all that in an editor, like you would traditionally have in a GMF-based editor, for instance, we just cut that in half. So we have on the client side the diagram rendering, editing tools, and visual feedback. That can be done in a generic way. And on the server side, the remaining functionality. And in between, we have a standardized protocol to exchange what the diagram should look like, so that the client doesn't have to understand the specifics of the DSL at hand, and the server doesn't need to be concerned with how that's being rendered exactly in HTML5. Okay, now let's continue to the model server. We've talked about that a lot already. So how does that look like in this demo? So I can, in Theia, just have two editors side by side as well. And if I now go ahead, let me just see that I did not forget something. Yeah. So we have this curse activity down here, and we have it here. And of course, to be politically correct, we don't want to have that particular name in here. Oh no, my demo crashed. Let me just reload. I think something went wrong. Let's just hope that it works better this time. Complain. Yeah, now it works better. So I've changed the complaint node here, and it also updates in the tree editor, and it should also work vice versa. So if I now add the correct spelling, then it would also update on the other side. I have been warned about my colleagues about the complicated demo setup and using the latest versions. So I hope you accept my apologies. So for the model server, how does that work? On the right-hand side here, we see an interconnected model. That's basically an abstraction of what we have in the entire tool here. So we have nodes that are some of the model elements and edges between the model elements. And the idea basically is that parts of that nodes and part of their edges are represented in the different editors. So maybe the structural editors represents edges as a hierarchy between a child and a parent node, and it represents some of the properties of nodes, while the textual editor might just represent another part of the model, and the graphical editor yet a different part of the model. But basically, all those editors have some overlapping properties and elements that they work on. Like we have seen that I can rename an element, and it has some graphical visualization as a node with text, and it also has a representation as an element in the tree. Now, the form-based editor that we've seen here was built on JSON forms. We had this GLSP-based graphical editor, and we will later take a look at an LSP-based textual editor. All of that could, of course, also, they could just try to communicate with themselves to somehow figure out who changed what. But you can already see if you have three editors, that does not work out well and won't scale. So the idea was to introduce a component that takes care of exactly that part, and that's the emf.cloud model server. All the editors connect there. They request the particular part of the model that they're interested in, and they can also subscribe to changes. And whenever they do changes themselves, they will push those changes back to the model server that can take care of updating the other editors. So the model server itself is a component of the emf.cloud Eclipse project. If you are familiar with EMF, I like to say that it's basically like a resource set with an editing domain, just with a remote interface. So in particular, it is not concerned with persisting the model. It is not concerned with versioning the model. It's just concerned with coordinating changes, parallel changes on the model by different editors. The features that it comes with is a command-based change interface, so you can send changes as commands to the model server. It has a notification mechanism via sockets, so editors in the front end can subscribe to changes. And it has some convenient model access with client APIs, like we've seen the TypeScript-based client API. Generators. So at the end, at some point, you want to derive some additional value from the model, apart from communicating about the things you would like to build. And one of the ways to do so is to generate some code. And I think it's here. Yeah, on the coffee file, we have added a contribution to generate code for the workflow. If I launch that action, I get some additional source code files, and I have Java source code here that was generated based on a generator. Now, for that model to text component, this generator in particular was built with Eclipse Extend, like maybe many generators are built these days. In existing tools, the generator jar itself was built with Maven. This jar contains some code to also be able to launch it via CLI and pass in the Theia workspace folder as a target for the generation. We've already looked at the architecture of the generator, so I'm not going to bore you with that again. Working with source code. So now that we have the source codes in the IDE, you might have noticed that we have a Java editor here. Basically, you already see the syntax highlighting, and that's actually really a functional Java editor. So you also have auto completion if you type correctly, and you could So that would be a valid program again. You've also seen that in between there was also syntax highlighting of things that are not correct. There's also refactorings in there. So if you, for example, select a string, you can select to just extract that to a constant. And in addition to just editing the code, you can also run it. So we've also generated a test case here. Along with the other classes. This test case basically tests the different activities. So it will also test the complain activity that we had built earlier. That was actually where the code was supposed to go to in the demo. So I'll just push it over there. And and you can see the nice syntax highlighting. Now I got a warning that there's an unused constant in here, and I don't have that here. So you can see that it actually works quite nicely. And now in the test case, I would like to also run it. I will add a breakpoint just before we run the complain activity. And I can just start debugging it. Now it holds on my test case, and I have the usual things. So I could now step into. There it creates my complain task. I will step over a couple of times. Now the task is being executed. That's interesting. Here is the pre-execute method, step into. And here we are exactly in the complain class that we have just edited, and we have our system out print. If I step over, we see that we even see it down here, welcome. And we can also see that local variables work. So we have the local variable with the welcome text in here, all the usual stuff you would expect from editing Java code. So before I dive into the details, just a quick reminder of what the language server protocol is, maybe with some little bit more detailed example. So the general idea was that you separate the concerns of tooling for editing code and the actual language smart, so that you could build an editor that is not language aware, but that can nicely syntax color code, that can do refactorings, that can run auto completions and the like. And then you would, for every language, have a language server that's specific to that language that understands Java, so that you know what can be auto completed, for example. And the advantages are obvious. You only have to write this LSP client once for a particular IDE, and it is language agnostic. And the LSP server only needs to be written once by the language maintainer, so it's a really neat difference. Down here is also an example how such an exchange could look like. So basically, the IDE and the language server exchange messages to, for example, retrieve an auto completion and things like that. So the enablers for that are the language server protocol. Otherwise, it would be quite difficult to create such an editor. The second enabler is the debug adapter protocol. That was responsible for the communication with the JVM about where is a breakpoint I would like to step over and things like that. And the Theia code editor, since it's Monaco based, so it's based on the VS Code editor, it just supports the language server protocol out of the box. It uses the language server to understand the language, in our case, Java. And Theia also ships with some UI to debug, and that uses the debug adapter protocol. And if we look at that from a more architectural point of view, we have the Theia front end and the Theia back end. And the LSP editor is just an existing contribution front-end extension that you have in Theia. And there is a connector that connects to a language server. In this case, it was JDTLS, the JDT language server, which uses JDT. It's also why some of the things look very familiar if you're familiar with the Eclipse JDT, because they're based on exactly the same code. And the same goes for debugging, so that you have the debug UI in a front-end contribution, and you have a debug adapter protocol connector, and it runs in a JVM, a Java debug server, which in turn uses the JDT language server. So with all that, and in the end, of course, we also launched our Java program that will be yet another JVM. So all in all, you get, for anything that ships, any language that ships with a language server protocol enabled server, and any language that supports the debug adapter protocol, you get this kind of functionality out of the box pretty much for free. Textual modeling. So in our IDE, we also have here a textual model. This is concerned with configuring the analysis, and it's based on an Xtext DSL, and it has some syntax highlighting as well. So I think you're not allowed to enter high numbers here, and you can also complete the different activities that are available. So I could do something with the activities here. So basically asserting that one activity has to happen before another activity. So that would obviously make not much sense. And I'll revert it back. So this is a textual editor with auto completion and the like. And this textual editor is basically the same one that we've just seen for Java. Now just configure it for a different language. So how does that work? The front end is the Theia editor, as I just mentioned, and the back end in this case is a DSL that was modeled as an Xtext grammar. So that might just also be from an existing tool that you already have. And Xtext offers a possibility to generate an LSP server. So basically, you get an Xtext LSP server for your DSL pretty much out of the box. For the front end, we just use the existing editor, and for the back end, the existing connector, but this time we connect to an Xtext-based LSP server. The only thing we customized about this Xtext LSP server is somehow it needed to know about the activities that are available. And that's a concept that's available in Xtext anyway. So this is completion providers. In this case, it's an activity provider. And this activity provider would be exactly the same in a desktop-based tool. And in this case, it communicates with the model server to read in all the available activities and to provide them for auto-completion. So why did we configure this textual DSL? Because we have a model analysis, and the model analysis can be run on this configuration file for the analysis and brings up a neat analysis visualization. It visualizes the execution paths and their probability. And this is based done on D3. So the front end is based on the D3 library, which is a really beautiful library to do visualizations. I claim that to do the same visualization with SWT or GEF would be much more complicated. And in the back end, we just fetch data from the model server because we need to fetch the different activities and the different decision nodes and what their probabilities are. And then we just calculate an analysis result from the data and push it to the front end. So we have this analysis UI in the front end, which is the button to trigger the analysis, and then basically an editor showing or a view showing the results of D3. Then we have an analysis connector component, which connects to an analysis service. My colleague Philip, who helped me in preparing this demo, wanted to try Kotlin for once. So this is a component written in Kotlin, but it runs in a JVM. And this analysis service in turn then fetches data from the model server to perform the analysis. With that, to the final feature. So the final feature, all that we've seen so far is just Theia running on a single workspace on my local machine. What if you want to deploy that more in a cloud-based fashion so that multiple users can have multiple workspaces? You can do that by using Eclipse Che. So I have a Che workspace open here, and in that workspace, I have my Theia custom IDE running with the models that we just saw before, and yeah, basically with exactly the same functionality. So how did I achieve that? This is done by running Theia on Che. Che is providing those multi-user workspaces, and then it has a server, and the server has different workspace configurations. So you can think of a workspace configuration as a configuration, which particular repository to use, which runtime technologies to use. So for instance, a particular JDT LS server needs to be running, and which front-end editor to use. And then you can go to the Che server as a user and ask it to deploy a workspace based on this workspace configuration, and you get a workspace. And you can do that with a different configuration, obviously. And in our case, that could be a Theia-based workspace configuration. And then you get another workspace, and it launches Theia on that workspace. Now, all of that is not directly done by Che. It is done based on Kubernetes. And this is a small excursion to how Kubernetes works in a nutshell. So in Kubernetes, you have nodes. Those are physical resources or virtual machines. So machines that you can connect to and that you can run stuff on. And then you have one very special node, the master node, that has control over all of those nodes. And in addition, Kubernetes has the notion of a pod. And a pod is a deployment recipe, what you could deploy on one of the nodes. And what you can do is, or basically this pod consists of a bunch of containers, or even only one container, and in many cases Docker containers. And what you can do is you can ask then Che, now I'm already saying Che, you can ask the master node of Kubernetes to deploy that application to one or multiple nodes, and it will then deploy those containers there and run them. And this is a very efficient way to deploy an application to one or multiple nodes, and it is also used by Che in the following way. So We still have the master node, and in this example, only 2 more nodes. And now we have Che, and Che is just a pod configuration. And I can now ask the master node to deploy Che. Now Che is running on this node and basically turns this node into the Che server node. So whenever a user wants to use this particular Che instance now, it connects to the Che server node. In addition, I can have another pod configuration that is basically the Theia workspace configuration of Che. Now, if a user comes along with a browser, they go to the Che server node and ask it to get a Theia workspace. Che will then go to the master node of Kubernetes and will ask the master node to deploy this Theia workspace config on an available node. And then in the end, the user will work on that node until the user doesn't use the workspace anymore and the node can be deprovisioned. What I didn't show before is this is what I basically did to get this demo up and running. So the first thing that I did is I launched a Minikube Kubernetes cluster, and then using gctl, which is a command line tool to deploy Che onto that, I launched Che. So that's really pretty simple to do. The difficult part is the packaging of such a Che editor. So packaging Theia into that Che editor, or a custom Theia into the Che editor. Just a small excursion on a migration strategy, because that's a question that comes up quite frequently, because people have existing tools and how would they migrate? And many times the first idea people come up with, well, let's just build that web-based version of our tool. Then let's wait until it has feature parity with the desktop-based version, and then let's just deprecate the desktop-based version. And the problem with that approach is basically you double your maintenance effort, because it won't work that you don't do anything else on the desktop-based version, and doubling the resources is really very difficult to maintain over a long time. So what we found quite useful with customers is to start first with defining a strategy and a time plan and building a proof of concept to see that this could actually, your tool could actually work in such a setup. And then on the short term, consider the migration that will come in the future for architectural decisions in your desktop-based tool. So an example for that is if you would then maybe build an analysis component, you would already use a web-based framework to do that and just retrofit that into your tool. You can then start to prepare your architecture for migration iteratively. So it means that you don't already start actively developing the web-based tool, but you prepare your architecture so that components can be better used in a web-based setup. Like we mentioned, that you could make the code generation into a service that can be easily called from outside. You could get rid of your hand-coded form-based editors and use a declarative framework. You could backport some of the, you could already have a new component, but then backport it with a browser widget into your desktop-based tool. Those are things to prepare your architecture. Then you could start to migrate high-value use cases, but not in a way where you say we will already reach feature parity, but in an iterative way. So you would say this use case is per se already useful for my customers. I would also deploy it, but still I have my old desktop-based tool. So that could be a review use case, for instance. And in order to do so in an effective way, you need to always single source those things as much as possible so that you don't duplicate the code for this feature, but you reuse as much as possible. And then long term, of course, you will just migrate use case by use case and eventually deprecate your desktop-based solution. So in summary, I believe that we are today at a point where web-based modeling tools are feasible in a cost-effective manner. It is easier than I would have expected to reuse and migrate if you follow some of the guidelines. And you can leverage some really unique advantages. You get this modern UI styling, just to name some, zero installation for users. And for some businesses, this is really an enabler to a cloud business model. There is open source components to do so, and they should be used, because otherwise you will have a lot of effort to do so. I mentioned Eclipse Theia and Che today, which we have made a really good experience so far. And there is a couple of others depending on your use cases, namely emf.cloud, GLSP, JSON Forms, and others. In many cases, you can reuse your business logic. Sometimes it requires you to refactor your existing tool to do so, but it's really worthwhile. I would never recommend to just throw away what you already have. And all of what you've seen so far, so this whole coffee editor demo is available online as open source, and you can just clone it from GitHub and run it. And as I said, so the call to action, if you're interested in those web-based tools, define a strategy and time plan as soon as possible and build a proof of concept. And do not expect this to happen overnight so that you could really have the full-blown web-based tool and then deprecate your desktop-based tool. Plan for an iterative migration. And with that, I would like to close, and I can still take some questions if anyone has some questions. Otherwise, feel free to also drop me an email or contact me on Slack. Is there any questions so far?
I don't see any questions.
Okay.
All right, so we'll just end it here. And if there are any questions, I'm sure they can reach out at you via your Twitter or any social channels. So thank you guys so much for joining our virtual Eclipse community meetup today, and we'll see you next time. Thank you.
Thank you, everyone. Have a good day.